Swayam Prabha. Digital India. Educated India.
So the talk today will have three parts. Yeah. Firstly, I'll briefly discuss about, not get into too many details, but briefly discuss about a few microcontroller boards that are there and what are generally used in various scenarios for IoT deployments. Then I will take you through a quick tour of the IDE that is used for Arduino programming. And finally, then I will get into some of the aspects of Arduino programming, the language itself. So with that, I think we'll wrap up this discussion on Arduino programming. So there are several boards that are available online. So one of the you can purchase it online. There are several kits that are available on Amazon and various other platforms. So one of the very popular boards is this ESP8266 board from Espressive. One of the important aspects of this board is that it comes with this Wi-Fi chipset, which is already built into the board. So you can do any kind of you can program any kind of application into the microcontroller, and whatever data that you are collecting, sensing, your sensor which is attached to the board is collecting, that can be sent via the Wi-Fi to intermediate gateway, and from there to the cloud. And so that's a very important aspect that's part of this ESP8266 board. There are some boards which don't have the Wi-Fi module, so that then you have to use an additional Wi-Fi board which you have to plug into the system. So it becomes very cumbersome, and the whole uh, the deployment becomes little bulky. So that's one advantage, and also this has this additional advantage that you have low power that you can achieve in these boards. Uh, of course, it's a very small board. If someone has already worked with it, you know that it's not that big a board. So the small form factor is also quite small. There are some other non-Arduino based IoT hardware platforms also. Like Intel provides some IoT development boards with a little bit more processing capability. So it all depends on what you want to run, right? The algorithms that you want to run, that will decide how what kind of processing power you need. So there might be some microcontroller boards which are not equipped with that much processing capability. So in that case, you will have to go with the boards which are available, which provide you that kind of capacity. But everything has its own place in the whole deployment hierarchy. So at the very edge that we call, that is very near to where the data is being sensed, you may want microcontroller boards which are very minimalistic, in the sense that you just want some very bare minimum algorithms to run, and there might be some more important processing that needs to be done, and very very expensive processing that needs to be done a little further away from the edge. So that's how the hierarchy works. And in such situations, you may want boards that are doing a little bit more, and so there are some boards that are providing those capacities. So Intel provides this Intel Edison board, which has comparatively much faster processing rates than what Arduino boards otherwise would provide. So there are several such range of boards. So you one of the boards that you will use in the simulator today is this Arduino Uno board. So that is something that uh, you will I mean, of course, in the simulator mode you will be able to work with this, but yeah, it's a completely different thing when you're working on it physically. Then, of course, the Raspberry Pi is also something that's used to do a little bit more of processing in that sense. So there are a whole range of IoT hardware platforms that are available currently, and choosing the best IoT platform for your deployment is already a very um, important task that any IoT developer needs to do. Yeah? So that's giving you a broad picture of how things are in this sphere. Okay, so before getting into Arduino programming, I also said that I'll go through the uh, IDE. So if you haven't used the IDE before, just to give you an idea of how it looks like, let me just. Yeah, so I'm assuming the screen is the IDE is visible to everyone.
Yeah, I can see it. What about others?
Yes, ma'am, we can see.
Yeah.
Okay, good. So this is what you would so there is this Arduino IDE that you have to install. There are I mean, it is very easy to find the instructions to install the Arduino IDE online. So I can provide you some details if somebody needs it afterwards. I could just send you a PDF talking about these instructions, but it's very easily available. Even if you go onto the Arduino website, you can actually find out all those details. So the IDE looks something like this, and typically after installation, what you need to do is there is this setup that you need to do. So um, firstly, you need to get all the details of what package that you need to install. Okay, so that let me just show you something through yeah, I have some details on that. So basically this is from some labs that we conduct. So we use this Node MCU board to do these experiments, which has the ESP8266 microcontroller. So once you download this Arduino IDE, there is a package that you need to install. So for that, you need to open the file preferences setting. So if you go here in the preferences, you will see the settings tab, and in the board manager URLs, you can actually give in the specific package that you want to install. So if it's the ESP8266 board that your microcontroller that you're using, then you can give the specific package related to that. Yeah, so that's one thing that you need to do. And once that is done, then you need to also install it. Yeah, so you are just providing that link there, and then you need to install the package. So for that, you need to go to the tools board. There is tools board, and here boards manager. Yeah, so if you click on that, and if you type in here, yeah, so if you type in here ESP 8266, then you can see, you'll see the package here. Yeah? And you can I've already installed it, so I don't get it, but if you haven't installed, you will get an install option here, and so you can install that there. So once that is done, you are now good to go. So you're ready to now start your experiments, and there are some configurations that you can do by going to this tools. You can select what kind of upload speed you want, what is the frequency. There are several settings here. Yeah, you can either go with the default setting, or you can select the setting as per your requirements. So I'll not get into the details of these, but there are a bunch of settings here that you can play around with. Yeah? So once that is done, you're good to go on the IDE, and you can start your programming exercise. Whatever exercise that you want to. So now, before getting into the programming aspect, I would like to show also something that if somebody has not used Arduino IDE at all, it will be interesting to start with. So if you go to the open uh, file open, you can actually see a lot of examples there. Yeah, so there are some basic examples that give you code for already things that are standard. There are some more advanced examples also. So there are lots of examples here that you already have, and you can build upon. Yeah, you don't have to uh, write your code from scratch if you are already if you are using some of these aspects that are there. Yeah? So there are things like LED blinking and all those basic things, and other things in terms of analog right, in analog reading and writing, digital reading and writing. So there are a lot of uh, things where you have code for interfacing with a button kind of input. So there are a lot of examples here that you can actually use and explore. So then getting back to so that's basically the Arduino IDE. And okay, so before getting into that, I'll also say what you do. So once you program, so this is a empty block of code. So when you open a IDE, it gives you this standard format. And we'll get into what these things are. But once you do the coding, you have to upload this. First, you need to verify whether you have written your code properly. So if there are no mistakes in the code um, in terms of syntax, or yeah, so you just need to verify all of that. So for that, you have this verify here. And once that is done, then you upload this code onto the microcontroller. So for that, you can use your USB interface, and there is a cable that you can use based on the board that you are using. So each board has its own interface. So you will also have the cable that they provide along with it. So with that, you can actually upload whatever firmware you have built now onto the board. Yeah, so that is what typically the exercise is. Once you write the code and then you put it onto the microcontroller, see if it's working properly. and if not, then you come back and work on your code. So there is another thing that also you can use, which is called the serial monitor. Now this is not I cannot open this currently here because there is no board connected to my laptop. So if you have the board connected to your laptop, this serial monitor is nothing but an interface where you can see some messages that are coming from the board. So if you want to, debug your code and see how things are evolving, you can actually print some statements which will then appear on the serial monitor, and you can actually see what is happening as the code is getting executed. So that's a good thing to have, and you will actually see the importance of it once you start working on it. So that kind of sums up the IDE part. Now let's get into the main part of this discussion, which is about the programming. Right. So how do you actually program for these Arduino boards? So just some preliminary concepts. The code that you write in Arduino for the Arduino boards is a lot similar to the programming language C or C++. Okay, so there are a lot of aspects that are taken from C or C++, and there are some things built on top of it, so that you can write your programs targeted towards these Arduino boards. So the language used is very similar, and the cycle that you have in development is pretty straightforward. So you write the code, you do the compilation, then upload is done, and then the code is executed in the platform. Yeah, so typically the code that you write in for Arduino boards are called sketches. Yeah, so the terminology is it's a sketch, and the compilation translates this sketch to object code, as is done in a lot of microcontroller a lot of programs compiled for microprocessors as well. So that's what is done, and in the run part, the sketch or the object code that you generate from the sketch is executed, and this happens as soon as the upload finishes. Yeah, so there if you click here where the upload button is, and actually you can see on the console here the code actually getting uploaded. You can see the status, and once that upload finishes, immediately you can see if there is some indicator that you have put in your code that flashes on the microcontroller, then you can see that it starts functioning. So that's how the flow happens in terms of building the code to running it on the microcontroller. So now let's get into the code part. So we have seen already in the IDE that I showed, there was this skeleton code, and that's what is shown here. So every Arduino code that you write typically has these two blocks. The sketch would have two blocks, and it consists of a initial setup block. So this is kind of a block. This is to prepare for how your code is going to run. So this is the initialization block where you prepare certain things before your code actually starts executing. And the loop is the part where you do the actual execution of your functionality, whatever you want to run on the microcontroller. So this is something that is so the both of them have different ways of executing, in the sense that this is an initialization part and this is something that keeps running, right? So that actually implies that the setup happens, or the code in the setup runs only once, and the code that you write within the loop runs all the time, as long as the board is the power is on. It keeps executing on the microcontroller mode. So as in C or C++, you have these functions. So these are void functions. So there are no return values from these, and they are written with using these parentheses, curly braces. So you can write whatever set of statements you want within these curly braces. Yeah, so that's common for both the setup and loop, or in general for any function that you want to write in any other function that you want to write in Arduino as well. So as I said, setup is this initial block, and this is the initial segment that is executed once the code starts executing on the microcontroller. So once that executes for one time, after the after this upload has happened, and once this upload has happened, this is executed once, or it can also execute if you reset the board. Okay, so once you reset the board, it has to start all over again, so it executes once more, or power up the board. So there are three places or three instances when this setup code would execute. And the main functionality of the setup board is that it initializes certain aspects that you want in your code. Yeah, so you could have some pins set up in certain ways. So yeah, if you look at so let me just show you how this board would look like. Yeah, so you have this board and you have several pins on the board, right? So if you have to interact in some way with these pins, you have to set these pins in you have to set the nature of how these pins are going to communicate. All of these things need to be done before the actual code starts executing. Yeah, so that's the whole point of initialization. So you need to set up what the pin modes are. There are some variables that you may want to initialize, some libraries that you want to have before the code starts executing. Yeah, so all of these things have to be part of the setup. And the loop part then has the intelligence that you want to put in the microcontroller. So that part, as I mentioned, as the name keyword suggests, it's a loop. So it executes repeatedly unless and until you turn down the power to the board. So this is mainly what happens. These are the two main functions that are invariably always there as part of the code. And you can keep adding functions that you want to use within these two functions. So you can always put your own code into the put your own function into the code structure, so that it becomes more modular. Otherwise the whole intelligence would go if you have a very long code. and everything is inside the loop, then it becomes very difficult to maintain it. So it would be good to have functions that you write separately and then you call within the loop. So let's look at then a simple example, okay, and that will kind of help to get started with what kind of things that you can do within the setup and within the loop. So let's say I want to use one of the pins of the microcontroller board, and I want to use that pin to do something. Okay, let's now not worry about what we are doing there, but we want to use that pin to do something. So firstly, I need to set the mode for the pin, as I already said, and that is done by using this function called pin mode. Yeah, so pin mode is the function that you use to set the mode of the pin. Now, the parameters that this function takes is firstly the pin number. Yeah, so you have to find out which pin you want to use, and then you use the number for that pin. Now there are some built-in numbers that are already defined. So this is what this specific word here means. The phrase here means LED built-in. So there is some number attached to it, and you also need to specify the mode of the pin, right? So there you need to specify whether you want to use it as an input or an output. Okay, so let's say you want to there is a circuit that you have built where you have this board and then you have some logic, and based on some conditions in the logic you want to turn on an LED. So there is an LED that is connected to a particular pin of the board, and that is the pin that you're actually initializing here, and you say that the mode is output. Yeah, so now it means that it is an output. There's an output that's going out of the pin, and now that is going to drive something, some circuitry, some circuit that is attached to it. So that's the whole point of saying pin mode, some pin number, and output. So you could also set it as input. And in such cases, you do it when, let's say, you want to read some value that some sensor is sensing. And in that case, so there could be different kinds of sensors, right? There could be digital sensors, analog sensors. So based on what kind of sensors you have, you can use the corresponding functions. But if you want to read something, some value that a sensor is sensing, then you can use input instead of output here as a mode, and you can use a particular pin that where you want to read the input from the value that the sensor is sensing. So if you look at the example, let's say I say pin mode 10 output. So what I'm trying to say here is I'm trying to put the pin number 10 as the output on the board, and then I use this pin by connecting something, some circuit there, which you will do these exercises in the tutorial. So you will build a circuit, and you will connect the circuit to one of the pins, and then you can see if you're putting the mode as output, how does that drive the circuit. Yeah, so so that's what happens. And um, so one of the things that happens when you say the mode is output is it actually provides enough current so that any circuit that is attached to it can be driven adequately, right? So if you have an LED, and if you don't provide enough current, then uh, the intended purpose may be to light the LED brightly, and that may not be achievable. So that's what the output mode provides. Now you could also have, as I said, the input mode, and you could use that in several cases, in case of sensor, or if you want to sense some button being pressed. That is also something that you can do using the input mode. Yeah. So that covers the setup. Now you could do various other things within the setup. I have just taken an example. You could also initialize some variables that you want to use within the loop. So we'll just look at this example currently. Yeah. So the other thing so the next function that follows after the setup function is the loop function. So here you actually execute the code, the intelligence, as I said, and this happens repeatedly, right? So one of the things, let's say we are trying to do something here where we are using this pin to write something, okay, onto the pin. One of the functions that you could use to write is digital write. So assuming that the pin that you're using is digital pin, let's say, and then you can write to that pin using the digital write. So digital write is a function that takes in two arguments. One is this pin number again, and it also takes in a value. So you can actually specify either a high or a low, and in uh, various circumstances based on what kind of board you're using. It could be and so based on the board, the voltages that it supports may be different. Some boards may support 5 volt as the high voltage, and it could also be a 3.3 volt. So based on that, the when you say high, digital writes that pin high, it actually drives the that particular pin to that voltage, that value of the voltage that corresponds to the high. And if you set the that pin to low, then it means that it is set to 0, or which is ground. And that's what is basically being done here. So there is another function that we have here, which I'll go into in the next slide. But this is what typically you would do with this digital write function. You specify the pin number, and you specify the value of the value that you want to drive that pin with. So when you do this, it means digital write 12 high. It means that the LED connect. Let's say there is some LED that's connected to pin 12. Then it will turn it on. Yeah. And similarly, you could have another function also written here if you are trying to read something. So there is a function called digital read pin. And here you just have to specify what is the pin number, and whatever value is coming into the pin. And of course, you have to specify it as the input mode when you're setting it up in the setup function. Then you're actually reading the value from the digital pin, and it could be a sensor value or some button input, or some other input that you're getting. Okay, so this is what you can do within a simple example that you can do within a loop function, and this keeps executing. Yeah. Okay, so there is one more part that was left out, which is the delay. Right? So delay is a function that takes in a time value, and the time value is in milliseconds. So you can specify whatever time you want, and this delay is a blocking function. So if you specify delay and some time, it actually blocks, and you cannot do anything else. So it has to wait until that time that is specified, time quantum that's specified there, finishes. Okay, um, so delay is something that you have to keep based on what you want to do. So after looking at that, so just to see, somebody can answer here. What do you think is happening here? So you have a digital write, there is a delay, then again a digital write, and again a delay. It's a very simple example, right? What is happening here?
So the LED is turned high, and then after 1000 milliseconds, it's turned low, and
Right.
then after that interval, it's again high.
Right. So this is just the simple blinking app, right? Okay, it's just turning on and off LED with a certain period. Yeah, so you can also do things like you can have the high turned on for a longer time and the low turned on for a shorter time. All these kinds of different things based on whatever your requirement is, you can do that. Okay, so that kind of gives us an initial look into what the structure of an Arduino code would be. Um, so as I already mentioned, the setup and loop functions, they do not return any value. They are void functions, and uh, in order to understand some of the syntactic aspects of the Arduino code, we need to understand what are the things that the compiler thinks as errors, and some of the things that compiler just ignores. So that while you do the coding, you don't have to bother about it. So there are some things that the compiler ignores, which you don't need to bother about. So if you put spaces and tabs before some code statements in the parenthesis, yeah. So if you put these things, the compiler just ignores it. So there is no issues created because of that. If you put commas, blank lines, that's also ignored. Yeah. So it makes it very easy. I mean, in the sense that if you accidentally put some character comma there, then it doesn't really crib, and it just ignores it. But one important thing that you have to keep in mind is that the semicolon, which you also have in C programming, that is something that you have to use. So that's a statement termination sign. So the semicolon has to be there, otherwise the compiler flags it as an error if it finds some statement without a semicolon there. So once you have the setup and loop done, and you have the semicolon, all the the constructs properly done, then the compilation happens fine. It goes fine, and then you actually upload the thing. The object code that is uploaded, the program flow is basically based on these two functions, setup and loop functions. So the entry point is the setup function, and the loop function is what runs repeatedly. So it keeps running infinitely. Yeah, unless and until you turn it off, it keeps running. So that is about the program flow. So one important thing that we so before we get into the serial communication part, any questions regarding the basic structure of Arduino programming, or anything that you have as some have as question that is related to that?
Yeah, you could unmute and ask, or if you type in the chat window, we can read it out.
Okay, looks
Yeah,
like
maybe we'll move on.
things
from
are fine. Yeah. Okay, so just to show that here, yeah. I'm just taking the example of this board, um, the Node MCU ESP8266 board, to talk a little bit about serial communication now. So that's something that is quite important. As I showed you in the Arduino IDE, there was this serial monitor, right? So that's in order to communicate messages between the Arduino board and the system that you're working with, laptop or your PC, you can use this serial communication. And it's, as we know, it's a simple communication that uses UART. um, and I'm assuming everybody knows what UART is. It's a universal asynchronous receiver, mode of communication, receiver transmitter mode of communication. So um, without getting into details of that, assuming that that's known, I'll just say what serial communication does. So it typically uses, based on the board. Okay, the board, there could be varying kinds of boards. So it could be a 5-volt board, the board that supports 5 volt, or it could be a board that supports 3.3 volt. In that case, your messages are either a logic 1 or a 0. And based on whether you're sending a logic 1 or a 0, it could be a 5 volt that is being used, or it's a 0 volt that's used. So based on the board, it could be 3.3 volt or 5 volt. Okay, so that difference can happen. So typically this communication happens through certain pins on the board. So if you can see here, I'm not sure if it's clearly visible, but this location that I am kind of circling using using my mouse cursor, I these are the two pins that are the RX and TX pins of the board. And these are the pins that are used for the serial communication. So you can actually send messages to the computer, or any system, the laptop that you are using this pin, which is the TX. And similarly, you can actually receive message from the computer on your Arduino board, using the RX pin. So in this particular Node MCU board, or the ESP8266 based board, you have the TX pin named is the GPIO 1 pin, and the RX pin is GPIO 3 pin. Actually, in different boards, the pin numbers may be completely different. So it could be a different pin number in the Arduino Uno board. So that's something that you have to keep in mind while if you want to use these pins for any kind of serial communication. And if you want to start any communication between your system and the RX and TX pins, then you use this function called serial.begin. So this function will actually perform the initialization to start any sending or receiving of data that you want on this RX and TX pins. Okay. So the way this serial.begin function is called is by passing an argument. So you are actually sending messages, and these are in bytes. So you have to so of course 8